In this short movie, I'm going to just talk about the derivative. Now, the derivative tells us about the slope of a function. For a linear function, the slope's easy because it's always the same. For a non-linear function, the slope changes. If you look at this graph, at point A, the slope's negative. At point B, it's flat or 0, and at point C, it's positive. So how can calculus help us figure out changing slopes? Well, first of all, let's look at the way we write slope. Notation is the way we write things. If you're talking about function notation, fx, then the derivative is written like f apostrophe x. You'll often hear me just say f dash x, and that means the derivative. If we're talking about a function in y equals format, then often the derivative is written dy over dx. Basically means change in y divided by change in x, i.e. rise over run. Okay, and that's the calculator has dy by dx. So these all mean slope or derivative. Now we should have found out from the homework that if you find the derivative of x cubed, it's 3x squared. So notice the cubed goes to squared and the 3 is at the front now. If you had 4x to the 5th, you get 20x to the 4th. That is, x to the 5 goes down by 1 power, and the 4 gets multiplied by that 5 that was a power. So 20x to the 4th. And then 3x squared, the 2 gets multiplied by the 3, to have 6, and the 2 goes down to a 1. So 6x, or 6x to the power of 1. Now, I just talked about these 3 examples here. So that means in general, if you have x to the power of something, the power goes down by 1 when you derive it, and the number that was the power gets multiplied. For example, 4x to the 5th, the power of 5 goes down by 1, and then the 5 gets multiplied by the 4 to make 20. If there's a number already there, like 3x squared, the n gets multiplied by the a, so 2 times 3 is 6, n times a, and the power goes down by 1 to n minus 1. And so here's a trickier example where you've got x squared on the denominator. You have to write it without fractions, and remember, divided by x squared means x to the power of negative 2. So 3 over x squared is the same thing as 3x to the negative 2. Now when we try to derive this, we multiply negative 2 by 3, which gives negative 6, and then the negative 2 goes down by 1. When you subtract 1, you'll have power of negative 3. Now back to writing it as a fraction, negative powers mean denominator, so it's negative 6 divided by x cubed. Lastly, derivative at a point. Right, using the power rule, if you've got the graph of x squared, the derivative is 2x because we subtract 1 from the power and multiply that old power by x on the left. Now that we know the rule for the derivative being 2x, we can find the derivative at any point. If x is 2, the derivative is 2 times 2, which is 4. If x is negative 3, the derivative is 2 times negative 3, negative 6. Okay, and if x is 5, 2 times 5 is 10, the derivative is 10. If you look at the graph, this kind of makes sense. If x is 2, the slope's about 4. If x is negative 3, it's quite steep downhill, and the slope's negative 6. If x is 0, 2 times 0 is 0, and sure enough, at 0 the graph's flat, so 0 slope. On the calculator, to find the derivative at a point, you do second calculate and then choose number 6 dy by dx. It'll take you back to the graph, and you put in the x value you want and enter. By the way, this is all on the graphing function, so you should graph x squared first and then do second calculate. Similarly, on the TI Inspire, graph y equals x squared first, Then menu, analyze graph, dy by dx is there, and then enter the x value that you want.